We've got our screen coming through properly, which is, well, it's going to make it a whole lot easier to actually do any sort of live coding if it's got an actual workable screen and a viable stream. Uh, so we're going to pick up where we left off at the end of last stream. But there we go. Let's pop up the terminal as well. So last week we were chipping away at converting the application that we got, the time zone application, from being this kind of hodgepodge of like interacting with the DOM and like just it was all kind of all over the shop and no real consistency to it. And today, yes, we're going to keep making it less consistent by continuing to build out our sort of like pseudo React-ish sort of thing. So let's pop it open to a new browser. I've actually been playing around with it a bit this morning, just tidying up a few of the other things that were not going to be particularly interesting to do on stream. So what I've done is I've converted the time zone picker, which is the other major component that we've got within inside of the code base. I've converted that across to using the create element instead of document directly within inside of it. So we've got this create picker that we provide an instance of moment to, so that we can unpack the time zones, and then it will create out our select element, which then has the children, which are the opt groups, and then the opt groups have the options within them, and so on and so forth. I've also done some little tweaks to the create element API, or like the functions we've got in here. So something as I was doing things between streams, just tidying up a bit of stuff, I came across a problem that if you returned an array as there was going to be scenarios where I didn't actually want kind of a container element. So if I think about this purely from like a React standpoint, that's where you might be doing a React fragment. So I've got something I don't want it to be in the DOM, but I need it. It is kind of like a pseudo container. And there was no kind of good way for me to do that. I was really only dealing with text or elements. Like that's the two things that you were putting out. So I've introduced a new element type, which is called a noop or a noop. And the way that will work is that, so if like here I'm creating the time zones to display. So that's if we look here, that's these things that appear across the main. Like I want to render all of those into a container. I don't need them inside of another container. So to do that, I'm just rendering it out with no element tag. And if it's got no element tag, then create element. Then the descriptor that I'm building out will make it a type of noop. Otherwise, it'll be element. And then finally, it will go through all of those, set up. Let's just simplify some of this. We go tag and props, and then children. So if the child that we've found is an object, then so that could be like an array. It could be a function. Like maybe down the track we'll have like function elements or something like that. But like it's more likely to be an array or the result of calling create element itself. That will then just that'll just leave it as a child. Otherwise we'll create text elements. So then, so we have a slightly separate descriptor for when we're doing a text element, so that we can, in our render function, if it's a no, then we'll just render out all the children of that, because we're just assuming that there's only children. We don't care about anything else. Otherwise, if it's a text, we'll create text node, or if it's or create an element for its tag, and then go over the props and events, and then finally render out any of its children. Now, I also I normalize the API a little bit between create the text element and the plain old element. Originally, like text element had a slightly separate descriptor, which then meant that there was much more logic branching that happened with inside of the render function. But again, I wanted to simplify that down. Now, so node value is the property you set of an element, of a text node when you're created to set the value of that. So you can provide it as the call to create a text node. You can provide text there, and that will set the node value. Otherwise, you can set it just as the prop on there. So that's what I'm doing, because that way I can just do this props and not have to go if text or if element. And then similarly, we could theoretically assign events to text elements. Practically, that's not really possible with the way that the API exposes itself. But at least in theory, you could do it if you really wanted to. Yeah, like the functionality is there, and theoretically, a text node could have children. It's actually not ever going to happen because the children is always going to be an empty array, just because of the way that we create the text element. But just kind of it's to simplify having to have all these conditional checks within it. No, I think it might just be you, Jack, that the screen has frozen for. It's Australian internet. Try reloading. It was funny. I was on a call for Ignite because we got Ignite next week, and it was one of those like speaker prep talks, and Damo was on there as well, and he asked the question to the organizers of like, what should we do if connection drops? And they're like, oh, does not everyone have a stable connection? We're like, no, we're in Australia. Like, a connection dropping? Yeah, like, there's a good chance of that one happening. that was basically the joke, was like, oh yeah, Australian internet. No, there's a good chance that the internet will drop at some point during our talks. Particularly for Damo at the moment. He's been doing a whole bunch of like network analysis to his like internet, because he's convinced that it's constantly dropping out, but the NBN provider he's using is not convinced that there's enough of a dropout for them to do anything with. So he's been doing a bunch of stuff himself. I know that Amy raises a good point there. Like, one of the pains of Twitch is that when you reload the browser, that you lose the chat history. I've seen what some streamers do is they just overlay the chat history constantly, which I don't know if that's really my preferred option if you're doing it like a coding stream, because you kind of want as much screen real estate available for the code that you're working on. And if you then got text like the chat in there, it could be a little bit distracting because you're losing some of the content. But the advantage of that is that if people come in late in the stream and stuff like that, is they can keep up with the conversation history. I find it bizarre that Twitch doesn't have like the ability to see chat for the entire duration of the stream when you join in, but it is what it is. Okay, so anyway, back to what we're building today. Like I said, I've just done some tweaks and stuff like that, and I did get it working again so that the minutes will tick over, because that was something I broke at the end of last stream. So that's now working again. It will tick over it. Yeah, you're right, Jack. It is a gap. See, that's kind of why I've got this open here in the terminal. I know that it's kind of hidden behind my head, but eventually it filters up higher. Actually, you do this. We go B and split that way, and then what is it going to be? It's going to be like this. Let me see. I think that's the smallest I can make. Oh, there we go. Look, I just got this little cutout box where my head sits, and then we have sitting directly above it the chat. Yeah, I really like this little TC node module that I found for just like showing the Twitch chat in terminal. Okay, so let's see. Yeah. This index file is becoming a problem. Like it's really ugly because it's still responsible for wiring up a bunch of events that we don't like. It's responsible for a bunch of orchestration, and I'm not a fan of that because it's really becoming cumbersome. It's quite inefficient when we want to update time zones. And so like every single second that we tick through, if we have a look at the way that we've got it working in the DOM, oops, it's there. Go. So the way that it works in the DOM, and this is the result of some hacks, is that we're just updating a couple of the inner HTML here of the span, and then we're doing the time, the date time property of that time element. And I mean, that works, but the way that I've had to do that, because we never actually get references to those DOM elements, is this really horrible method that I've got down, like this event handler down here, that's just, this is a hack and it's only temporary, where it does a whole bunch of nth child selectors to find the things and then update them. Really not ideal, but the reason that I've done it this way is that the original thought was, hey, why don't I just get it to call the render function again and just like blow it away and start again. That's to a degree that's how you can kind of think of what React is doing. Like it's attempting to blow things away, but it's not really doing it that way. Because, well, it's got some intelligence behind it. But what I found was doing that was actually horrendously poorly performing, because you basically create an element, it lives for a second, and then you destroy it. And you do that n number of times for all the offsets that you're displaying. And the more offsets you're displaying, the slower it's going to be. And then that means that you kind of like, you end up like some will be there for like a second, some will be there for fractions of a second if the previous render didn't take, it was taking too long. It's like, yeah, okay, I agree, this is probably a terrible idea. Let's just use some CSS selectors to go through and do that sort of stuff. But I really want to improve this. So the first thing I want to look at how we can do is a bit of performance improvements with the way that we're actually building out the DOM. Now, if you think about the way that you build a DOM element, or the way that you build out a complex set of DOM hierarchy using JavaScript, it's a fairly synchronous process. So we don't create this section, we create all these sections inside of it, just collapse those out. So we create each of these, and then inside of that we create this, we create its child, and then we create its child, and then we create its child, and we create then its children, and then and then we add them to the DOM, and then we go on to the next one. So at the moment, like it's not going to perform particularly poorly at the moment because I've only got one. I've got 5 there, but if we were to expand this out, to have like, maybe we're showing like 10 different offsets, which I think is about as many as I'm currently showing on my the thing that I'm using at the moment that I'm trying to build a replacement for. And like that's 10 top level elements. Each of those has like one child, and that one has then 3 children, and then inside of that we have at least another 3 children. So like we're talking dozens of elements, and the more elements you got to create, the more props that you set on those, the slower it's going to be to render out, and the more time that the browser is not being able to do things that it really would prefer to be doing. Like the browser has other things to deal with rather than just building out DOM elements for you in JavaScript. It's kind of the opinion you probably should have done that in HTML initially. So we want to allow the browser time to do the things that it's got to do, and then also render DOM elements so kind of do its own scheduling. And I just saw Amy popped a message in chat. I could take some actually I've got a CSS idea for you, Amy. But I'll ping you offline because it's a little bit of a secret project at the moment, and it is nothing to do with a time zone application. But if you've got an existing application, I have some ideas of some fun things that we could do with it. Yeah, so send me a message on Messenger or something, so I don't forget. Oh no. So you'll be able to do it on stream. I just don't want to announce the idea of what we could do on the stream. Well, like Hacktoberfest doesn't start for another 12 days. So it's like 12 days. Yeah, but I have an idea of something that could be fun. And I'd love to collaborate with you on that if you're open to multi-people on the stream. Anyway, so back to what we're hacking away on. Yeah, first week of October, that's fine. We can make that work. I can make that work. That's, like I said, it's 12 days time. Plenty of time. I've got like a conference before then. Ignite is next week. Anyway, okay, so we want to give the browser the ability to do the things that it needs to do, and not just be constantly waiting for our code to complete before it can get back to the shit that it's got to do. And the best way to do that is not set timeout. So like that was, I did some research before coming on today. You know, shockingly, I did some research before coming on today. And initially I was like, oh, you know, you just use set timeout, and that's how you can do it. But it turns out actually that's not the best way to do it, because set timeout is just chucking things inside of the event loop. So then it's another thing on the event loop. So it's not allowing the browser to optimize for when it's ready to run things. It's just got to keep popping things off the event loop. Like the JavaScript runtime just keeps popping things off the event loop that has to be done. Instead, there's another API. Let's go to the MDN. It's request idle timeout. And wow, that's, did I manage to get Bing to return a 0 result stack? Impressive. MDN request idle timeout. Does it? Wow, MDN doesn't have request. Wait. Oh no, sorry. It's request idle callback. Callback, not timeout. No time. That's, yeah. I can spells today. Okay, so this is ignore the fact that it says it's experimental. What's it? Well, it's compatibility. Oh, it doesn't work in Internet Explorer. It doesn't work in Safari iOS. I care about browsers that are going to keep themselves up to date on a regular basis. So request idle timeout. Basically, what it does is you give it a callback function. So this is the thing you're going to do when you've got idle time as the browser. And it will then also tell you how long that you can run that process for. So if you're doing something that is going to be potentially wrong running, you can basically say, well, like, have I got enough time to complete? If not, I will park it and pick up this next time round, which is kind of what we want to do in like building out a bunch of this DOM work. Like we don't want to do it straight away and just inject it straight in the browser. We want to build it up in the time that we've got available. So for that, come back to our code. We're going to leave the render function alone, and we're going to leave these two where they're at. And we're going to create a new function, and we'll call this work loop. So this is the thing that's going to be running, and this will get a deadline. And then that will do something, and we'll request idle time. Request idle. Don't tell me I'm not going to get any IntelliSense for it. Work loop. Well, so we're going to call that, when it's got time. So we're going to let should stop work is false. So we'll just have a flag because we're going to have we'll keep looping and checking the deadline to work out whether or not we can keep going, but we're also going to work out whether or not we've still got stuff to keep doing. Like there's no point in keep running the loop if there's no point in running it. So we'll just do a while loop, and then while we we're also going to need to track the things that we're going to do. So that's the next unit of work, and that will be nothing initially because we haven't defined a new unit of work. So while there is a next unit of work, and we shouldn't stop work, we will set the next unit of work to, we're going to do unit of work and then that will be the next unit of work. So it's basically going to be a sort of recursive function, and then we should stop work will be equal to whether a line time remaining, and that is if there is less than one. So time remaining, like I said, I did some research of this beforehand. Where is it? The idle deadline. So idle deadline will give you a time remaining, which is the number of milliseconds left in this current, it says idle period. So how long you've got left to go. If we run out of time, then we're going to end up at 0. Like we'll get a 0 value. So if the time remaining is less than 1, which 0 is most often, like generally speaking, 0 is going to be less than 1. So if it's less than 1, then we're going to we'll sort of like bail out and stop. And let's just create that const do unit of work, and that will take the next unit of work, and then it's going to do stuff here, and that will be an assignment, not an equals. There we go. Okay, so that's the starting point of what we've got. Like it's essentially going to be this unit of work, this work loop is going to be triggered kind of as soon as we kick off. It's going to iterate through and then eventually render out stuff. Now we're probably going to, like at the moment, this is just going to call as soon as this function starts, but we'll need to have some smarter way to when we schedule the initial call to that, because if you've imported this module, well, we're not going to do anything until you're actually trying to start rendering things out, which I guess that will be fine if the the next unit of work doesn't have anything. Oh, and we need to make this request idle callback work loop. So then it will stop there, and then this is basically a perpetually running unit of work. So it's always attempting to do things, which does mean that you're potentially going to run this function a lot more than you need to run it. That's cool. We can deal with that, because it also means that as your code is updating things, it will, if you've got like event handlers that are triggering that are updating things, they will then immediately get picked up for it to do, because this work loop is just constantly being fired off in the background. Right, but so if we think about, well, we've got this next unit of work. Like, what is that unit of work? Like, what's it going to be representing? Now, from a React standpoint, this is what a React fiber is. So fibers in React are it's essentially a object structure that represents the virtual DOM the thing that we've created using the create element API, and the elements that we have to render out. And then it does a bunch of intelligence about working out how to build that out and then render it. So we're going to need to kind of put this all together, because it's actually the fiber is the thing that we care about most, not the render function right into the right into the DOM itself. It's going to set something up that eventually our performing I'm going to call that perform unit of work, not do unit perform unit of work, because it sounds more professional. We're going to hit a point where we've built out our structure, and then we're ready to start inserting stuff into the DOM, and that's going to happen within here. Now, fiber tree kind of we've kind of got that in terms of we've got the starting points at least of that, which is like our root element, which is going to be the no-op element, or it's going to be a select element or something like that, and then it's got children and children and children and children. But the way that the fiber tree is built out is that it will go all the way down to the very bottommost element within inside of the children hierarchy. So it finds the deepest child, and it will build out that child. Once it's done that, it will then look, well, it knows it doesn't have any more children because it's the deepest one down. It will then look at its siblings. So if we've got, actually, if we come back to this display, so an example of something with siblings is this H1 has a child of time, and then that time has children which are create element, which is 3 spans. So we'd render off the first of the spans, so the first child, and then because it doesn't have any children other than the text element, it will then render out its sibling, which is the span, which is the blinking one, and then its sibling will be rendered out next. What's that, Jack? My old manager's calling you. Yeah, Jack's in trouble. So if we don't hear from him again, it was nice knowing you, Jack. It's nice working with you. Yeah, so we're going to keep rendering out the siblings until we run out of siblings. Once we've run out of siblings, we're going to go back up to the parent of this collection of children and render out its siblings. So essentially the aunts and uncles of these spans, which doesn't actually have any. We don't kind of have that structured up here, but or do we? Do we have something where we can have a look, see? Yeah, so once we've rendered out this time element, we'll go, does the H1 have any siblings? Yes, it has a H2, and it has the div, and it has a div. So these are aunts or uncles, depending on which gendered pronoun you sort of want to use there. I was just sure, there's no, well, at least I'm not familiar with any non-gendered pronoun that represents the, your parents' siblings. And parents' siblings is kind of verbose. So headless CMS is being especially, do you mean as in cost wise, not performance wise? So do you mean the hosted plans are $300? Yeah, that seems expensive. You can totally host your own WordPress for much less than that. You just use WordPress as a headless CMS. Let's see what Amy says to that one. Or Jack. If Jack was still here, he could share some opinions on WordPress as well. I am going to close all others because I'm getting confused at what files I need open. Okay. Yeah, 3 to 300 is a pretty big jump. Okay. So right now, our render function, we're going to, we're actually going to use the majority of the logic that's in our render function. The only thing that we don't want from here is going to be the append child, because this is just building up all the DOM elements. But we might need to think more intelligently about how we do that, because at the moment the render function, yeah, for a no-op. No, we shouldn't need to. Just thinking, because so I'm thinking like, this is essentially building out what we're calling a fiber tree. But the problem is that this render target is eventually what it hits, and that's not ideal. Kind of don't want that one to be there. Actually, you know what? I think I could actually optimize this slightly differently. So we're going to pull that out. And then we're going to push this code to there. If it's not equal to a no-op, then we can do that. If it's text or create element tag, yeah, actually, hang on, let's have a look at what's going to happen now. We've exploded. So element render target is undefined because okay, so maybe this was a poor refactoring idea. Let's come on. Why is this so hard to just get my mouse on the right darn line there? There we go. Okay, so the child was the section and the element was undefined because the tag, because there was a no-op. Oh no, because what happens if we do document.create element with undefined? Where is console? And clear that. Document.create element undefined. Interesting. Null. What happens if we have like a null element in the DOM? So if we get rid of this if statement entirely, what does it actually render out? Document create element tag. So tag is empty string. Oh, wait. Yeah. So it doesn't. So we can't do on an empty string. It doesn't like doing that. Okay, well that's fine. Whoa, console. No, let's get rid of that. There we go. Tag colon undefined. What happens if we end up with like an yeah, that's probably a terrible idea, huh? Yeah, that was a terrible idea. Okay, no, let's undo this whole refactor here. Git status. Oh no! Let's not just undefine. There we go. Control. Okay, cool. So there we go. So yeah, okay. It'll be interesting. We might have to remove the idea of this no-op element and think differently because the render target. But we'll see. We'll see because that render target is the current DOM. Okay. Anyway, I'm getting slightly sidetracked. Now we're going to grab this chunk of functionality, and then we're actually no, we're gonna rename this function. That will be create DOM. And then instead of appending, we're going to return the element. And that's not how you spell return. That's how you spell return. So, and then we're going to do const render. That's going to take a element, the element descriptor, and then that's going to take the render target and put stuff in the DOM. Okay, so that's there. Create DOM. No, it's not going to be render. That is going to be... Is that just going to... No, that's not going to take a render target. Because this is just going to build out each item, So how are we going to tackle this one here? Now, instead of pushing, that up, I'm gonna get rid of this no-op concept because I think it's making my head hurt at the minute. Yeah, so we're going to get rid of that. We'll get rid of, no, not that one. Yeah, that one. That's in create element. That will just be element. And then we will come back into timezone display. And that can just be a div. We'll just add some more divs. Yeah, that's frozen there. Okay. And we'll comment out that because this is going to be responsible for creating just the single element. So we don't need that. We're not going to need children. Okay, so we're going to need the yes, I think that's going to be right. We need the tag, the type, the tag, and the props because that's what we're building to create the element that is then detached from the DOM, which is what we're going to be building. And then it will be elsewhere that we'll start walking that tree because this is just going to be a standalone function. Now, the render function. The render function is going to start by setting our next unit of work to be our starting point. We are going to render out the DOM is going to be the render target. So that's the DOM element that we want to render out to. We're going to need the children, which will be the element that we're trying to render. So actually that's descriptor. No, we'll call that element because that's what they actually named the function. Yeah. Okay. Yeah, there we go. So that should actually almost, because then, so we have, let's see, so we've set up so this is the do unit of work. Wait, rename that one back. That should be perform unit of work. That will be the next unit of work. And then if the next unit of work DOM doesn't exist, so we haven't created the DOM element for that, we're doing the next unit of works DOM will be create DOM for the next unit of work. Yep. Okay, cool. And then if the next unit of work parent exists, then we can do next unit of work parents DOM append child. The next unit of work DOM. Yeah. I think that's going to be right, because so this is going to be executed in a loop. Let's have a look what's going to happen. Like, how badly broken is it? Pretty badly broken. Awesome. Now, oh yeah, actually I'm probably going to want to remove that ticking event because it hasn't. Yeah, I'm gonna need to remove that tick event because we can't guarantee that this is been set up yet. So let's get rid of that because now we've got an order of execution problem. We could try and update the DOM before we've actually attempted to render the DOM. Okay, well that didn't work the way that I was hoping. Let's see. We come into here. We'll go into create element. We've hit render. Okay, so the element that we're creating is the thing with a bunch of children. Oh, yeah, actually that's... I know. Oh, no, sorry. That's fine. That's correct. So the render target is the main. It's there. Yep. Now, the DOM is going to be the render target. Okay, so it's done. Okay, so but it doesn't have a parent. Oh, wait, hang on a sec. I think I need... Yeah, I probably want to make the parent of the root because we're... Okay, so that will do... No, wait. Yeah, that's right. So there isn't a parent. No, oh, I haven't... I probably need to, do a bit more in this next unit of work. But I'm curious. Add a log point. Next unit of work. Now, how frequently does that log out? Interesting. I was expecting that to have continued to log. Oh well, well, it's not stuck inside of here, is it? No. Okay. No, there's not enough done in perform unit of work. So there's not going to be a parent because this is the root. If you're the root, we don't actually do anything with your. You're never going to have a parent, so we're not doing that. Instead, we are going to get the element, which is going to be the next unit of work, children. So that's the children of the next unit of work, and then for const of element. Wait, no. Wait, hang on a sec. Is that guaranteed to be an array? Let's just say, yes, that's guaranteed to be an array. So for that, what do I call that element? I'm going to call that children. So then I can go child of children. We will create const unit of work will be, so we're going to then do the type will be the child type, props will be the child props, the tag will be the child tag, children will be the child children. Actually, we'll do this dot 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 child, and then we are going to do the parent, which will be the next unit of work. Actually, that should be next unit of work. That is the current unit of work. Yeah, parent will be the current unit of work, and then it will have no DOM because we haven't defined that yet. Okay. And then wait, no, a for of loop's not going to work because I'm not going to be able to tell if something is going to be a child or a sibling. So we're going to do let index equals 0, and then we'll do while index is less than children length, and then we'll just get rid of that and that, and then the child will be children I index and if the index is 0, so that's going to be the first child, then that will be the current unit of works child will be the unit of work. So this is the next one that would be there, and then else I'm going to need to track siblings as well. Let priv sibling is null. So if it's not, then the priv siblings sibling will be the unit of work, and then the priv sibling will be the unit of work, and then index will be incremented so that we keep trucking down. So that's going to, yeah. So we're going to go through all the children of the current unit of work that we're working on. And then while we've still got children to go with, we'll create a new unit of work. That unit of work will copy all the properties from the child. The parent is going to be the current unit of work. It doesn't have the DOM because we haven't rendered that yet. We'll schedule the we'll schedule the build of the DOM elements later. And then if it's the first one, then it's going to be the child of the current unit of work. Otherwise, it's going to be the sibling of the previous one that we went through, the previous child. And then we're just going to keep shifting that along. So just kind of, I was like, looking at that in the DOM, which we actually can't do because I don't have anything in the DOM anymore. Yeah. Okay. Now, that's getting close to being all we need. Probably what we need to start building up is the rest of the fiber tree so that when perform unit of work runs, next time it can build out the DOM elements. So for that, we'll do if the current unit of work has a child. So once we build out this thing down, if the current unit of work has a child, then we will return the current unit of work's child. So because that will be the next thing that we're going to work with. Otherwise, we're going to let the next unit of work, yeah, will be the current unit of work. And then while the next unit of work, so while we still have something, if it has a sibling, we're going to return the sibling. Otherwise, the next unit of work will be the next unit of work's parent. So then we'll jump back up to look at the aunts and uncle elements against it. And then that will then return... yes, that should never hit a point where we're returning undefined when we expect to not get an undefined. So... oh, look at that! It actually built out the DOM elements. It is broken because of that div. That div, because, yeah. You know what I could do is, so, yeah, I'm just going to move the CSS down a bit, CSS. And then hash main is going to have colon first child. So put the display flex on the first child. Wah! No. Wait. That's not right. Oh, how do I target just that one? No, there, hang on a sec. Is it that one? How do I specify only the child? I think that's, yeah, that's it. It is that. So only apply that. Yeah, so I basically just moved the flex box down one level to there. Yeah, and the greater than symbol is the descendant selector, I think. Oh, we're gonna have to MDN descendant selector. Descendant selector. Oh, it's the most expensive selector. No, it's not. It's not descendant selector. It's no, not selectors. Is it immediate? No. Child. What do we call, Amy? What do we call the greater than symbol as a selector? I forget. Is it only child? No. Properties? No. CSS selector, bang. That's not how you spell a selector. Okay. What's it called? It is specific parent. Okay, yeah. So the first child where its specific parent is the direct child. Yeah. Good. Oh well, yeah. We just got to inject that because we've put an extra like this dev element in here, and yeah, it's not ideal, but until I go back and refactor some others. Oh, let's just uncomment this code and just see. Like, does the ticking updating work? I think it does work now. It does. Excellent. Give it a moment and it should tick over the hour. Yeah, sorry, ticked over the minute, not the hour. Yeah. Oops. That one. So this is the link Amy's just popped into the chat. Child combinated. Yeah, that's what I was looking for inside of MDN. Yeah, so that only matches the elements. Yeah, direct child of it. Yeah, so then I don't need to do first child here. I can make that a div, so it's only the direct descendant div of. Ooh. Oh yeah, there is a possibility of out of order things, isn't there? Yeah. Yeah. Anyway, we're getting closer. We're getting closer to things not being quite as dodgy. Because now that we're creating this sort of like work tree thing, we can manipulate that work tree dynamically, and then just have it continually picked up. So, but let's create a commit point. Get status. And actually no, I just have let's quick diff it. Yeah, so it's that. Create element. Yep. Okay, so we're going to add star.css and git add this file. Git commit. So we're just going to add these two that we have the minor change in, adding an extra div in because we heart. Oh no, come on. We heart divs. The more divs, the merrier. And then we're going to add the create element and shifting the element creation into a more scheduled jobby thing. Okay, so that is how we're doing everything, but we're still like it's still maybe not optimal. Because close all others, and again, like looking at the way that React sort of does this is, we're always creating new DOM elements. Like we're never able to update them. Like we kind of want that sort of prop-esque experience where as things change, we can then like update props and then that can cascade down rather than having to like poke into the DOM and touch the different elements, which is sort of the approach that we're doing at the moment using the CSS selectors. So, and well, I guess there is also another problem. An application this simplistic, it's not really a big deal, but if the more offsets that we add, the more chance that is this to happen. It could be partway through a render. I've created a DOM elements and putting them there, and the browser goes, "Hang on, I need to interrupt and do something." So you could end up with a partially rendered DOM. So what we kind of want to do is sort of track a bit more like what is being built out as the DOM elements, independent of the actual like inserting them into the DOM. So we're going to do that. Like we need to track the root of sort of where we're up to, and we'll do that. Let's hide this performance. Yeah, work loop. That's all good there. Create element. Oh, and we can get rid of that bit of code because we don't need it. Do that sort of inline, and then that becomes that, and we're going to const, because const as much as you can. Yeah, okay. Let's just git amend. Cool. All right, so update that now. So we need to track the current stuff that we're in progress of building out the unit work for. So we're going to do that with a work in progress. This is not the work in progress unit of work, because that would be and sort of an oxymoron in definition. No, this is going to be the root. That can be null initially, and then instead of assigning that, we'll do that can be the whip root, and then the next unit of work. So like on the render phase, the next unit of work is actually just the whip root equals whip root, because it immediately like the render immediately sets that up. That won't have had any ill effects on the browser as the way it runs, because we're not actually doing anything with the work in progress. Instead, but what we want to inject is kind of React calls it a commit phase. So you've got the two phases. You build out your DOM, and then finally you commit that DOM to, so you build out the elements for the DOM structure that you're targeting, or if it's React Native, to the native app, and then you commit that once you've built everything out, so that you don't have this chance of like an interrupt coming in and going, oh, hang on, we've just modified. We just need you to pause for a second of building out your elements. We'll get back to you in a moment. So we're going to create a new function, and we'll call this commit the root element. So this will be where we actually write our to do, write to the DOM. So this is actually where things will actually happen. Man, I'm not paying a huge amount of attention how I'm writing my own code today. And then inside of, let's just move some of this stuff around. It's more logically ordered. So first thing we do is create elements, then we create DOMs. Yep. Then we render out the DOM, and then the we'll be inside of our work loop. Before we schedule the next timeout, if there is no next unit of work and the whip root is complete, then we are going to commit the root. And lastly, we need to build out that that whip root a bit more. Yeah. So const commit work for the current unit of work. So so for the current unit of work, we're going to commit that, which is essentially where we're building out the DOM and then appending it to the DOM thing. So if there isn't a current unit of work, we're just going to return, because we've hit the end of our tree structure, or we've been given a bad tree structure, for either. And then from that, we're going to const DOM. So that will be the parent, which will be the current unit of works parent DOM. So that's the DOM element that we're targeting of the parent, and then the parent append child current DOM, and then we will do commit work on the current unit of works child, and then commit work on the current unit of works sibling. So this is basically like, if there is no child, then it'll bail out. Just means that we can be more recursive. If there isn't a sibling, then it'll bail out. That's what the if conditioning is doing up there for us. Commit work is assigned but never, What do you mean it's assigned but never used? Is it just unhappy because I'm using it within like this? Because the assignment is actually going to be up here, and then we're going to commit the work of the whip root child, and then the whip root will be null because we've cleaned it all out. And as far as we should be concerned, well, nothing is different. Now, you see, so that time we did actually get like an interesting render. You see that was because the browser obviously tried to do an interrupt, and it was probably because it had already rendered out a couple of the elements and they needed to blink, so it needed to play a CSS animation. So it's just kind of paused and gone, hang on, I can't render everything out yet. We'll hold back, perform the thing that we need to do, and then come and continue on with our render process. Wait, I'm actually ever updating the whip root. So we do that. Hang on a sec. I'm never actually updated the whip root as we run along, am I? Does that make sense? Because the render function, we only call that on initial entry point. Do we need to modify it anywhere? No. No. Yeah, I think this is making sense. It's making sense in my brain. That's probably all that really matters. Okay. Now, let's commit this and git status. Yep, just that one file. Delaying the insertion to the DOM until the very last minute. Wait, hang on a sec. No. I have. We can append. We can amend. No, I want to get rid of this, don't I? Perform unit of work. Because inside of perform unit of work, we are actually rendering out. But we don't want to be rendering out there. So we don't want to be appending to the DOM there. Yeah. Whoops. I think that's fixed. Yeah. There's the possibility that we're adding things to the DOM multiple times. Yeah, that's better. Let's go Husky. There we go. Wait. Git status. Did I? Yeah, no, that. Yeah. So perform unit of work is going to go through and build out all the DOM elements, and then we will commit it independently once we have built everything out. Yeah, that's making that makes more sense. It wouldn't. Yeah, the whole point was optimization was to push the commit phase, like the putting stuff in the DOM, to as late as we could. Now, on to the very final thing that we really need to tackle. Setting us up for the very final thing that we're going to need to tackle. But the biggest problem that we've got in the way that we're building elements at the moment, and that is that we are never actually going to be modifying right. The only way we can modify elements is to use the DOM selector and to go through and find the elements and then modify them. We can't. What I want to be able to do is this refresh time zones list. Because it builds out. Well, it's actually not building out the elements anymore. It's building out our descriptor tree. But we have a hack in place, because here's the render function. Like we call this render time zones. We render it out, but then every time we do, like, we actually go through and we would have to delete all of the elements every time we wanted to do a render. So that the way that we get around that is that we have this nasty, great big function down here that goes through, finds the CS, like uses CSS selectors and the nth child selector and whatnot to find the DOM elements and then like manipulate them directly, which, yeah, really not ideal. So what would be better is that, and I'm just gonna whoa, what did I do? JavaScript. Pop something up there. Key maps. No, I don't want any additional key maps. Basically what I want to be able to do is I want to do render, and then we'll do create element, and then this would be the, so this would be like a div, because it's just like a dumb container element. It doesn't really matter. It's going to have no properties. And then so we'll pop that there. I'm just going to do some indenting. So this is the goal of what we want to be able to do, is like have this done at the top level. That can go there, and then that will be create element, and then that will be a header, and then that'll have no properties, and then this will be where we would call the create picker function. So we'd render then create picker there, and then we would have create element, and then this would be the section, and currently it is like the ID of main, and then it will have the like create time zones. Like that's kind of what we're trying to get to, and then that will be to like well, I mean, that doesn't actually need an ID anymore, but document dot get element by ID foo, like whatever that element is called on the page. Like where, so that's what we want to be able to do, and then we want it so that as the time ticks through, this function is kind of self-contained, and it knows about that change. It can then update its own unit of work essentially, or kind of like force a rebuild of the unit of work for the, ideally not the whole application, but that kind of doesn't matter to a degree if it's the whole application, because it's fairly efficient at just building out that tree structure. And then just sort of as it's picked up by that request idle callback, it will just be like, oh well, I got stuff to do. I will then update the elements, as needed. So and then that just sort of it happens like to a degree automatically for us, because we're just kind of coincidentally updating things. Now, React calls this reconciliation. It's reconciliation engine, because it reconciliates. It's got reconciliation of the changes between what happened in the code currently. So like the last time it was rendered versus the current time you're attempting to render it. It will then it performs a diff of those changes, finds elements that are being added, finds elements that are being removed, and finds props that have changed their value, and that's including event handlers. And it will go through and just make those specific modifications. And this is where React, at least for a long time, and synthetic benchmarks aside, has always touted that it is more performant than most of the other JavaScript UI frameworks or libraries, because it will only update the specific things that need updating. It does a whole lot less DOM manipulation, and DOM manipulation is one of the slowest things you can do in the browser. So that's where we want to get to. Like, we're not there yet. We can't do it quite yet because we have to support this idea of reconciliation. And to do that, we're going to need to be able to track the currently rendered root structure of our unit of work structure. We need to know what that looks like, so that every time render is called, which is every time we do some updates, we are tracking what we can do a diff against what like the last known state is. So we're going to chuck in a new thing. We'll call it current root, because this is going to represent the current root that we've rendered out. Now, the current root we actually want to update when we're doing when we're completing the commit phase. So we've committed all of the DOM elements into the DOM. So we're doing the current root will be the previous work in progress root, and then we're going to null out the work in progress root. So that we clear that out, right? But the other thing that we kind of want to track is, well, what did it look like last time here? So on the work in progress route, we're actually going to put, I'm going to call it prev, because that's kind of what it is, and then that's the current route. So what did it look like previously? The initial render phase, the previous view of this, well, it didn't actually look any different because it was exactly the same. Sorry, it was null. We didn't have a starting point, but then future render calls would update that potentially, and also we will be able to we can update that programmatically because we're going to sort of want to track this structure. So yeah, we're going to do that for like every single item within inside of our structure. Now, where are we going to be doing this? We're going to need to do some stuff to the perform unit of work, because the perform unit of work at the moment, well, it doesn't. It just kind of creates the DOM element. We need to make it a lot more intelligent. So it'll create a new DOM element, but it's going to need to track the previous stuff as well. So, yeah, this function here that is, well, essentially building out our unit of work tree, kind of everything up and, yeah, so this perform unit of work function, like all of this code here, this is responsible for building out a unit of work view of things. So we actually kind of want this a little bit, well, we don't want to be, when we're performing a unit of work, we want to be able to build that ourselves elsewhere, because we're going to probably want to, I think we want to do that maybe when we're creating, maybe that create DOM method down the track, we'll see. But I'm going to rename this function, and we're going to call this, well, let's call it reconcile child, because that's kind of what it's doing. It's reconciling a child as we iterate through. For, yeah, the current unit of work, we're going to reconcile that. And then we're going to create our perform unit of work. Oh, hang on a sec. No, that's too much. It's just this stuff. Building out the file. Building out this bit. We're going to do reconcile child. It's going to take a current unit of work and do that. No, children. It's going to take the children, isn't it? And current unit of work and children. Yep. So then we will reconcile child. That's not how you spell child. I will have to fix that one in a second. The current unit of work and the children. And let's rename that child to spell child correctly. Okay, so that's that done. Now, yeah, because then whatever we can pass in the current unit of work, or we can create a whole new unit of work to be passed in there. And let's just change that to the whip unit of work. So that's I didn't want to call it let's just call it whip, because it's the work in progress structure. It's the work in progress unit of work. Whip unit of work. And then that is I'm just going to call that new unit of work. Just so, things are a lot more verbose. If we were running a minifier, we could actually improve that and fix up these variable names, but we're not, so we can deal with it not being particularly being somewhat verbose. Now, what we need to do is we need to make the unit of work a little bit more like when we're performing the unit of work. No, wait. When we're reconciling the child... hang on. I think I need to think. I might go grab a drink. I'll be back shortly. We'll work out precisely how we target this. Oh, hang on. What's my browser notifying me about? Did I break something? No, I didn't. Okay. I'm going to go grab a drink and then think through this a little more. Back in a couple of minutes. if we remember to unmute myself, on the main mic. Okay, so this reconcile child function is going to need to do a couple of things. Right now, basically all it's doing is it's building out the first pass, and well, we're only ever sort of dealing with the first pass scenario, so that's kind of fine. But as we put in the functionality so that it can do an additional update pass to itself, well, that's where we need to have some intelligence. So what we need to do is we need to be able to determine whether or not, well, like what kind of reconciliation are we performing? Are we going to be performing like an update to an existing element? Are we performing a insertion of a new element, or are we performing a removal of an element that's been deleted? Because, well, that's the possibility of something that's happened. So what we're going to do is we're going to first work out whether or not there's some previously known stuff around this. So let's call this one old unit of work. So was there a previous unit work for this one? So the whip unit of work has if it has a previous, and the whip unit of work previous had a child, because we're actually building out the first child here. So while we have children in the index, and the old unit of work is not null, because we initially set things to null. But we need to make sure we remember to always set things to null. Okay, so yeah, if there's a previous, then we'll grab the child of the previous, because that's what we're actually going to be working with. Like the old unit of work is always going to be, we're always starting with the child. And then we sort of shift things to be siblings and so on and so forth. Now, we have the child there, and what we're going to need to do is, before we create the new unit of work, well, actually, we're going to need to change the way this new unit of work is created. We're going to need to essentially compare, because right now the unit of work is just like, here's a new DOM for insertion in, like here's a new bit of information that will be inserted into the DOM. So let's do this in a couple of passes. First off, well, let's detect whether or not they are the same element type, because if they're the same element type, we know that there's going to be an update. Well, there's a good chance that that's going to be an update rather than a full replacement. Like if it, well, actually, even if they aren't really the same element, if they're the same element type, we can actually just reuse the existing element. We don't have to create a whole new DOM element and then remove and reinsert. We can just, well, basically strip it back to bare bones and create again. So same type. And that is going to be determined whether or not the old unit of work exists and the child exists, and the child's tag, yes, is the same as the old unit. Wait, is it tag or... Oh, do I look at... No, because tag's not always there. Type. So type will be element or text node, whereas tag is the tag only exists for DOM elements. So because we want this to be applicable for text nodes as well. Equals to the old unit of works type. So if they are the same, type, we will perform update to existing element. Else, if we have a child and it's not the same type, so this is going to be insert new child. Update to yep. So we're going to insert and then else if no, sorry, it shouldn't be an else if. We'll just do these as else statements, particularly because this last one. So if we have the old unit of work and it's not the same type, then we have a delete the old element. I'm just going to call that element. Keep doing that. Yep, there we go. Okay, so those are the three things that we need to do here. We need to update if they're the same, insert if it's new, remove if it's old. And so we don't want to use else ifs here because there is the possibility that we are inserting. So if you're inserting and removing kind of in the same pass, because the child at this position, like if you've reordered elements and they're of different types. So let's say that you our H1, H2, if we flipped their order, that's actually that's a removal and an insertion that we have to do. Like, so basically we have to remove both of them and we have to insert both of them just in a different order. So you need to make sure that like an else if statement would have meant that you wouldn't be able to, you wouldn't hit the block the second time. Yeah, like realistically, you're not going to have them the same type. And like, so you could do else, this could be like an else block and then an if, but it's kind of, you're starting to create a Christmas tree effect for little to no value. Right, so now we have that. Now we're going to start creating our new unit of work. So the new unit of work is going to have to be, unfortunately, let bound. New unit of work. And that will be dull to start with, because I can't do it as a const because it's going to be the result of, well, we're going to do something in each of these different ones here. So the new unit of work is actually going to be, it's going to have a type, which we can use the old, we'll do ... on the old unit of work, but the props are going to be the child props, because that might update, and then the children are going to be the child children. The previous is going to be the old unit of work, and we need some way to indicate like what kind of operation we're performing here. So this will be the operation, and this will be an update operation, because we're going to be updating that element. Now, let's see, let's just go parent, just because maybe I'm going to be TypeScript would be really helpful right now. Just like, parent is going to be the current unit of work. Yep. Okay. So that's when we're doing that's an update operation. Yeah. Yep, so that's the update operation done. Now it's on to insertion of a new element, which is actually a whole lot easier because, well, that's kind of what we wrote here. We're just going to grab everything off there. We'll undo that. The previous is going to be null because we won't have had a previous. The operation is going to be insert. Is there anything else? Yep, there's the parent. Yeah, okay, yeah, sorry, I did have to do parent explicitly because parent doesn't, I mean, it would be coming from old unit of work, I think. But if the old parent has been changed, yeah, no, we don't. No, we'll do that. And then lastly, we're going to do deletions. But for deletions, we're going to actually need to. Well, we're going to need a way to track the deletions. So and we're not going to create a new unit of work for this because we're not doing anything with new units. There's no point creating something new for this. We're just going to mark the operation of the previous unit of work there, and then now inside of so we're going to deletions. So we're going to create a. It's not. Yep, and then no, that will be null. Let's just null it out to start with, and then we'll initialize deletions equals an empty array when we start, and then we will do deletions dot push old unit of work. Okay, so that's that. And then we don't need to do anything else with the other stuff, I don't think. Well, I mean, we're going to need to do something with those deletions, aren't we? Let's see. Let's come back. We haven't broken anything yet. And we have... it's not rendering out. Why isn't it rendering out? Let's get rid of our loop. Let's get rid of this listener. Okay. What have I've broken something more. That was not a good idea this close to the end of the stream. I've broken something. I've broken something more than I wanted to break. All right, we're gonna have to. Let's do a quick step through of the logic here. So, perform unit work. We reconcile the child. Am I not actually building out the work tree properly? Okay, let's start with our render function. Okay, no. Come in here. So we hit the unit of work. The current unit of work is on the DOM. Yep. Okay, so let's reconcile the children. So the previous unit of work doesn't have a previous tag. Oh, that's why, because hang on. This is so if the previous unit of work doesn't exist. No, that's not right. Oh, hang on a sec. It's an or, not an and. Not an or. Yeah. if there are still children or we don't have, yeah, that's better. Get rid of that. Ta-da! Okay. Nearly scared myself there with fundamental breaking of things. Okay, well, we've only got 10 minutes left. Despite what the clock says, that was just because I managed to have some failures early on with setting up the stream. So, do we reckon we can get any of this stuff? No, because, well, so inside of the commit phase, I'm also going to need to do deletions as well. But we're not actually implementing anything that's working with the deletions yet. It's probably not ideal, but we'll just deletions dot for each commit work. So we're just going to commit each deletion, and then we're going to need to do an overhaul of the commit work function so that it will look at what kind of operation we're performing, whether it's an insert or a like an append or an insert or an update or a deletion. So that will be, let's go let's go const operation equals current unit of work. So if the operation is a delete, then we will look at the current unit of works parent dom remove child current unit of work dom. And then actually, I probably need to do deletions will be an empty array once we have committed everything. Else if the operation is a insert, that's where we will do that one. And then else if the operation is a update. Update. Okay, to do update current element with new props. And then we'll just do an else of throw operation is not supported. Yeah, so we should never actually hit that, but just chuck in some error handling for funsies. Again, we haven't broken anything, well, other than I keep commenting out. Whoops, not that file. Now everything should still be updating. Let's just see, we'll inspect that element. Cool, so the direct DOM manipulation is still working, but we are close to being able to move away from that, because ultimately what we're going to be doing is just like re-rendering the whole component hierarchy on these event changes, and fingers crossed we can just treat them sort of like prop updates that we would do in React, rather than doing it sort of inline as we're doing. Okay, so I'm just going to commit the point that we're up to now, and adding the start of a reconciliation engine to update, insert, remove elements as required. Right. Well, we'll wrap up a couple of minutes early today. Actually, probably won't be a couple of minutes early by the time I just sort of ramble on for a bit. But we're getting close. Once we can update, once we implement this sort of update props thing, which is going to require doing a whole bunch of sort of comparing of prop values, and at least in theory, like, we should also look at the props that are currently on there versus, so we look at all the existing props, we look at the new props, we find out the ones that have been removed, the ones that are being added, the ones that have had value changes, and then we're going to have to do all of those updates. We also need to look at event handlers, so we're going to need to make sure that we unbind event handlers as they are removed. Like, some of this stuff we don't need for the application we're building, but part of this is I want to kind of show off how you build like a React style engine, library, or whatever you want to call it. But yeah, so we're going to need to, so this update branch in here is actually going to be a little bit more complex than the other two that we've got there. They're pretty simplistic. But once we've got that done, we can then look at how we do things. We'll go back and kind of refactor out this index to not be that like horrible mess of the code in the way that it's written, and actually write like a top level app component. Essentially, and then inside of that we have children components and children and so on and so forth. But yeah, so that'll be the structure, and that's what we will tackle next time on stream. Now, I don't know if I'm going to do a stream next Friday. Next week is Microsoft Ignite, and I've got a bunch of stuff that I'm going to be doing for that. So I will have spent a lot of time on recordings and cameras and stuff like that. So I may take next week off, but I will I'll update Twitch as needed, just to let everyone know, and also put it out on social media whether or not I am going to stream next week. But yeah, I'm excited because we're getting close. The final pieces of the puzzle are coming together, and then we can get back to writing CSS and making things look pretty, and tackling some of the ideas that I've got around how we can improve the design of this, and all the other stuff that I've got planned for the application that I just simply haven't got time to, we haven't got to building yet on stream. So yeah, thanks for hanging out with me today. Like I said, I may be back next week, I may not. Otherwise, feel free to register at Microsoft Ignite and pop in the sessions I'm doing. I'm doing one on Visual Studio Code and code spaces. So if you want to learn a bit more about that, you can find a session there. And we've got a bunch of other sessions around those kind of tech. We've got some announcements coming out in the web space that I'm excited for. But yeah, thanks for stopping by, and we'll see you next time.